Hi, my name is Marcus.
And I'm Ernestas.
We're third year students from the Camel School of Mines, University of Exeter. We're here in Carboneras, sunny Spain, right on the seafront. Our hotel where we're staying is literally behind us there. There's actually some students getting on with a regional geological synthesis as we speak behind us. And this trip is really kind of a culmination of the 3 years we spent at CSM, Camel School of Mines, so far. We've got the 3 different courses here, so there's the pure geology, applied geology, and then engineering geology and geotechnics as well. And one of the really nice things about this trip is it's a chance for us to all be together. We're all staying at the same apartment. Some of the tasks we all do together, but it's also a chance for us to split up into our different specialities and work on the more specific modules that we've been working on. So for example, be that mineral exploration and resource estimation, environmental land remediation, or some kind of geotechnical assessments and stability analysis as well.
The reason we've come to this specific area of Spain, the Betic Cordillera, is to look at world-class exposure of metamorphic, igneous and sedimentary rocks. There is also some really interesting abandoned gold mines, as well as some really great evidence of tectonic activity.
As well as the obvious geological aspects of the trip, we've also made this little accompanying video showcasing some of the field localities and some of the fun we get up to here at CSM, showing you a bit of what we're about. So yeah, we hope you enjoy.
So we're here at M.Geol in Carboneras, just south of Carboneras, and M.Geol is an extinct volcano. So it would have been a seamount in the sort of Neogene, starting in the Teutonian and into the Messinian. And what we're seeing here on the flanks of the volcano is a succession here of volcaniclastic sediments. So these have volcanic debris, so mainly boulders and rocks in mainly a carbonate matrix. So what the students are doing here is that they're logging the sediments and making observations on the nature of the sediments in this particular section. And as they're going along, they're recording the differences that they see in the different sediments in the succession here to try and work out the specific episodes that happened here. If we look at the rocks in this section here, we can see that there's distinct differences in the clast size. They're all fairly rounded, so there's obviously been some transport going on in this succession here. The matrix appears to be dominated by carbonates, a fairly fine carbonate mud with some trace fossils in it, but the succession essentially is indicating that the volcanic material is sort of being reworked from the volcano down the slopes into a sedimentary basin where this carbonate mud is precipitating. They're worked into these distinct beds, of course, and fine-grained or finer-grained material.
Okay, so here we are at the top of M.Geol. We've walked up through a whole succession of volcaniclastics, and now we've reached the top, and we're in something which obviously is very, very different. What the students and myself have found up here is basically a whole stack of disaggregated small shell material as well as larger shell material. A lot of that shell material looks like it's been very happy living in high energy environments, but then it's been washed off what was probably a reef top and down to form these extensive beds that we see behind us. It's currently very difficult from one locality to just figure out exactly where we are within a reef setting, but as we've come up onto our seamount, we've obviously got a complex patchwork of different environments. And one of the interesting features we can see in the cliffs behind us here is actually a line of clasts that are now being displayed as small voids in there, which are actually volcaniclastic bombs. And beside that, we see a whole series of beds of further bioclastic materials. So we're obviously seeing an interaction of these volcaniclastic and then carbonate reef environments.
Megan's drawn a quick diagram just showing what we think is going on. So when we look at the actual rock especially sort of in this region up here, and look at mineralogy, we see unusually lots of garnets in it, as you know. So we also saw related garnets, garnet mica schists preserved as sort of, we think of these xenocrysts within the actual rock itself, as we've got an example of. And these in the rock have sort of melted margins, and the larger clumps sort of preserved, but as you get into smaller pieces of this, they're almost melted completely. And we think that the actual garnets we're seeing in a lot of the volcanic rocks are actually derived from the garnets left behind sort of in here, where most of the rock's been melted, but for some reason the garnets are still stable and so preserved and left in the melt, which has then been erupted and formed the rocks around us today.
Well, hello everyone. I'm going to be talking about the Messinian salinity crisis today. Generally, it was about a 60-metre change in sea level associated with it. It's thought to be uplift associated as well. Thought to be due to the westward rollback of a subducted Tethys Ocean lithosphere along with associated asthenosphere upwelling.
So this first section here, some of you may have noticed that the laminae and the mudstones were being pushed down by the gypsum crystals. And it's because during diagenesis the mud sediments are more, can be deformed.
Hi man, we're digesting.
Hiya, I'm Patrick, and this is gypsum deposits which happened during the Messinian salinity crisis. Basically, Africa and Spain moved into each other, and the Strait of Gibraltar closed, and it caused a lot of evaporation and a lot of precipitation of salt, and eventually gypsum. And which these big massive crystals which have occurred just at the bottom of a big sedimentary unit. And, yeah, it's pretty impressive looking.
Disperse or put that down into the settling ponds that are over there, which now forms part of the botanical garden. Okay, so materials will settle and probably at regular intervals be dug down and put down into the waste dumps. So that's a continuous process of how you're getting ore out in this particular case. In order to do the processing, you need about 1 kilogram of cyanide per ton of ore. it's by using zinc. So adding zinc to the solution gives a simple replacement within the cyanide so that you get a zinc taken into solution, and that causes precipitation of gold and silver. So it's filtration of that liquid afterwards means you can recover the gold and silver. So that's sort of a crude outline of what the processing is like.
Where we get our samples of the clay that we're going to test the moisture content in. First of all, we take it over to the corner here. We'll crush it down in pestle and mortar. It's further crushed down by another pestle and mortar, and then it enters into the sieve. The sieve has holes of 0.63 millimeters, so it's very fine. Right, after sieved, you will weigh it with the scales.
Keep it over because you don't want to lose it. Because what you'll notice is,
and you'll try to get around 40 grams of clay.
Yeah.
And what you want is to add about 10% water at a time, so 4 grams or so.
I also I forgot where I was, but I can hear something spinning near my head.
You spin my head right round when you go down, You spin my head right round when you go down, Hey, I got the house with my swagger, hop in that window, I got places to go. People to see, time is precious, I look at my Cartier out of control. Just like my mind where I'm going, the women, the shorties know nothing but clothes. No stopping at my Pirelli's on. Cause it's meant to be ours. We keep a fadeaway shot cause we ballin' this platinum Patron every hour.
1, go!
Ain't nothing my Benjamin Franklin's. A couple of grands, I got rubber bands. My paper planes making a dance. Get dirty all night, that's part of my. We building castles that's made out of. She's amazing, on fire blazing, hotter than Cajun. Girl, won't you move a little closer? Time to get paid, it's maximum wage. That body belong on a poster. I'm in the days, that bottom is waving at me like, damn it, I know you. You run the show like a gun out of holster.
Day 3, the Sorbus Basin. Behind us you can see the lovely, fuck me. You can see the evaporite sequence. And so last night went fishing, caught a big one. Got a big Adentex. There you go.
That's good. That's good.
That was horrifically awkward doing that.
1, 2, 3, go!
I'm spending my money, I'm out of control. Somebody help me, she taking my bankroll. But I'm king of the club, and I'm wearing a crown. Popping these bottles, touching these bottles, watching the asses go boom.
And currently on top of a volcano, so there should be some interesting rocks to look at.
Alright, so I'm with the boys here. I'm going to talk you through my gear. First things first, you got to get that traction. Got some boost on the sole, some trail running shoes, nice fat lugs, Continental soles, good grip on the rocks, nice long comfy walking socks from Sports Direct. Then we got the shorts, obviously, because obviously we're in southern Spain. Even if it's a bit windy, you got to have the shorts on. Lightweight cotton t-shirt, just to get that sweat, wick the sweat off the armpits. Little bit of a fleece going on. Got the fanny pack with all the Geology bling. Got the hand lens and the Clino in there. Topping off with obviously the big nice comfy rucksack. Lots of lightweight stuff, but lots of stuff in there. And then obviously the big wide brim lid and the hard hat on top. And if it's sunny, we got the little sunnies on there.
The field course takes place in the beautiful surrounding of the Baltic Cordillera. Wait, pause it.
Yeah, just to follow up on what you're saying, I do agree. So we primarily have lapilli, which are 2 to 64.
Okay. The reason we've come to this specific part of Spain, the B.Sc Caldera. I'm trying serious. The reason we've come to this specific spot. The reason we've come to this specific spot. Okay, serious. The reason we've come to this specific. The reason we've.
Team Greece!